So children, you see some more examples of aromatic species. This is, you see, 1, 2, 3, 4, 5 carbon ring. Its name is cyclopentadienyl anion. Cyclopentadienyl anion. You see, it's aromatic species. All the three conditions are fulfilled. It's planar. Then it has got how many pi electrons? 1, 2, 3, 4, 5, 6. This lone pair will be contributed in the pi system. So 6 pi electron. Okay, so second condition also is fulfilled. Let me tell you here is that 4n plus 2 pi electron. It's called Huckel's rule. Huckel's rule. And there is complete delocalization of pi electron, because this electron can come here, then this can come here, then this can come here. So complete delocalization is taking place. Say next species, it is it's a how many membered ring? 1, 2, 3, 4, 5, 6, 7. 7 membered ring. So its name is cycloheptatrienyl cation. Trienyl in cycloheptatrienyl cation. You can see here also all these conditions are fulfilled, so it is also a aromatic species. This is phenanthrene. It is also a aromatic species. So children, you can expect in exam, a species will be given to you. You will be asked whether it's aromatic or not aromatic. Now, there's been one thing. Why is aromaticity so important? Aromaticity is important because this double bond which we are seeing, they are not pure double bond. They are not pure double bond, as you have already seen in case of benzene due to resonance. This double bond is not double bond. They have double bond character. These double bonds are not double bond. They are not pure double bond. They are stronger than single bond but weaker than double bond. And that is the reason why, in spite of having double bond here, they do not undergo normal addition reaction, which ethene undergoes, which ethyne undergoes. They do not undergo normal addition reaction, and that's the reason why it's called aromaticity. Okay, now children, next reaction that we will be doing is, next topic that we will be doing is, we have done electrophilic substitution reaction of benzene. We have done halogenation, we have done nitration, we have done Friedel-Crafts reaction. All these things we have done. Now, I am writing all of them one by one. I am writing them one by one. First is halogenation. Halogenation was like this: benzene plus say Cl2 in presence of AlCl3 as catalyst. We got here Cl plus HCl. This is one example of electrophilic substitution reaction, and we know if we go by mechanism, here the electrophile is Cl plus. Cl plus is the electrophile, Cl plus is called chloronium ion. Then another example of electrophilic substitution reaction is nitration. Nitration is benzene plus concentrated nitric acid in presence of concentrated sulfuric acid. This mixture is called nitrogen mixture, and here NO2 comes and water. This reaction is called nitration. Here the electrophile in this reaction is NO2 plus. If you find out by mechanism, you can easily get it. And this is called nitration. This electrophile is called nitronium ion. Then sulfonation. Sulfonation, it is benzene plus H2SO4. This is concentrated H2SO4. Okay, then so you see here SO3H group is coming. This is called sulfonic acid group. This is sulfonic acid group, and in here the electrophile is SO3. Electrophile is SO3. Then Friedel-Crafts reaction. Friedel-Crafts reaction are of two types. One is alkylation. Alkylation is like this. So methyl chloride in presence of AlCl3, and this methyl group will come here. Plus HCl. This is called Friedel-Crafts alkylation, where alkyl group comes into the ring, and here the electrophile is CH3 plus. Another reaction is acylation. Acylation is benzene plus CH3COCl. So here you see COCH3 group has come. This COCH3 group is called acyl group. And here the electrophile is CH3 C double bond O plus. So children, you see all these electrophilic substitution reactions I have written. These are very important reactions that you have to remember. You should also practice their mechanism, and you should remember what are the electrophiles in these cases. These are very important. These reactions will also be coming in class 12. Now, since we have written this reaction with benzene, now this can happen with also benzene derivative. This can happen also with benzene derivative. What I mean to say is, suppose say we are starting with chlorobenzene. We are starting with chlorobenzene, and if we carry out this reaction, suppose if I carry out halogenation, that is halogenation takes place with chlorine in presence of AlCl3. So like before, one Cl will come. So naturally it will come at these positions. It will come at this position. It can come here, it can come here, or it can come here, and coming here and coming here is same thing, coming here and coming here is same thing. So the incoming Cl has three positions where it can come: this one, this one, this one. So where will this Cl come? Now I can say the answer. The Cl that will come, it will come at this place and this place. So I am writing the product here. It will be one product will be here, this one. So Cl plus is coming here, Cl plus is coming here, and there can be another product also. Another product also where that Cl plus is coming here. You know that when this is at 1,2 position, it is called ortho. When it is 1,4 position, it is called para. So we get here ortho isomer and para isomer. We get here ortho isomer and para isomer. Now suppose if I carry out nitration of chlorobenzene. Suppose if I carry out nitration of chlorobenzene. For nitration we require HNO3 and concentrated sulfuric acid. Then here the electrophile is NO2 plus. Now NO2 plus where it will come? Again NO2 plus will come at this place and at this place. So I am writing the product here. One product will be this, and another product will be this. So you see, once again ortho and para isomer we get. So whatever electrophilic substitution reaction you carry out of chlorobenzene, the incoming group will come at, we say it will come at ortho and para position. And that is the reason why we say that, we say this one important thing, this halogen group, that sentence I am writing here, halogen group attached to benzene ring. Halogen group attached to benzene ring is ortho para directing. So halogen group attached to benzene ring is ortho para directing. That means any electrophilic substitution reaction you carry out of chlorobenzene or other halobenzene, the incoming group always comes at ortho and para position. Now in the next video I will show you, the reason that why it comes at ortho and para position. So you should remember that halogen group is ortho para directing. There are some other groups, which are ortho para directing, that you have to know. You will find out in your book, like had it been OH group here, OH, it is ortho para directing. Had it been here NH2 group, then it is ortho para directing. Had it been here alkyl group here, then also it's ortho para directing. So you should know which groups are ortho para directing. Similarly, there are some groups which are meta directing. which are meta-directing. There are some groups which are meta-directing. I am giving an example of that. Suppose we start with a compound. We start with a compound called nitrobenzene. We come in and suppose we carry out an electrophilic substitution reaction of nitrobenzene. We can carry out any one of this reaction. Suppose we are carrying out halogenation of nitrobenzene. So chlorine in presence of AlCl3, chlorine in presence of AlCl3. So this is for halogenation. Now it is seen that the incoming Cl plus will not come at ortho position. It will not come at para position. It comes at this position, that is meta. It comes at this position. So I am writing the product here. The product that we get is NO2 and here Cl plus HCl. So we get meta product here. That means we can say that this NO2 group is meta-directing. Why NO2 group is meta-directing? That also will be explaining in the next video. And in this way, there are some other groups which are meta-directing that you'll see. NO2 is meta-directing. Had it been here CHO, it's meta-directing. Had it been here COOH, is meta-directing. So in this way, you should remember, you will find in your book, list is there which are ortho-para directing, list is there which is your meta-directing. So you have to remember those. So this much for now. In the next video, as I already said, we will be discussing the reason why these groups are meta-directing, these groups are ortho-para directing. Until then, goodbye and have a nice day.